What the hell is AGI? Are we here yet? Have we accomplished general intelligence? What is AGI? Do we even know it yet? Have we defined it yet? Is it a humanoid robot that can walk, talk, think, and sense like human beings? Does it have consciousness? But what is AGI? Is AGI predicting cats versus dogs? Or is AGI allocating my capital better than me at the best fund possible and having the best long and the best short position possible? Is it when the model has intelligence or when the model can think and the model has memory? What is AGI? Have we even defined artificial general intelligence the way we should have been? And are we there yet? If it was only intelligence, then I think we have already arrived. If it was just memorizing the internet, then I think we might have arrived. It was just allocating my capital better than me, then also I think we might have been arrived. But what exactly is AGI? Is it generally intelligent humanoid robot that can literally do anything that we want it to do, that can walk, talk, and do housekeeping, do capital allocation, do whatever we want it to do better than us? If intelligence was just prediction, predicting cats versus dogs, predicting the best stock possible for the next 30 days, predicting the next token, predicting what is there on the internet that I can simulate better in order to write better code, write better sentences, write better stories, and be more creative. If it was just prediction, and if prediction was also only intelligence, then wouldn't we have already arrived at AGI? Why would we still fiddling around it? Now, we have been talking about why the need for artificial general intelligence, or how has the work been going in, to bring up AGI. Let's just have a retrospective and let's look back. How have we evolved, especially algorithm wise, right? And systems wise. So, we first wanted to build systems that could do some sort of prediction. So, what all did we have at our hand in the 1900s? We had some basic statistical formulas that could do formula based prediction, right? So let's say we started from the core concepts for mean, median, and mode. And then we evolved into fitting a line. We wanted to predict a certain variable ranging from negative infinity to positive infinity. Now, sometimes it was a price, sometimes it was a cost, sometimes it could be anything, right? So we wanted to represent a lot of data and we wanted to fit a line on it. So what that really means is we had some data. We assumed that it has certain linear relationships, and we wanted to represent it using a line, which was again a linear model which followed the equation y is equal to mx plus c. Then we saw we want to extrapolate it into multivariate regression. Then we saw why not we evolve our systems to be able to represent some non-linear data, which is why don't we infuse in some non-linear curves from a simple linear curve? Why don't we infuse in some non-linear curves, right? Then we went on to infusing non-linear regression, which was an extension to a linear regression. Non-linear regression helped us represent all the non-linearity in the data onto our model. So all of these while we were learning how we can use calculus, which is nothing but gradient descent, to simulate learning. Now, what were we learning? We were learning certain weights and parameters. Now, these were sometimes the weights and parameters of a line. Then it evolved into becoming the weights and parameters for a nonlinear curve, using polynomial regression. Then we wanted to separate classes. We wanted to build systems that could classify between class A and class B, or class 0 and class 1. So that's how we binary cross entropy loss came into picture, logistic regression came into picture. The idea of decision boundary, learning a decision boundary, starting with a random decision boundary and then evolving into such a decision boundary that both the classes are nicely separated, and binary cross entropy loss came into picture, right? Now we were able to do classification, regression, supervised learning, unsupervised learning. Then obviously we wanted more and more non-linearity in the data. The idea of loss functions, the idea of non-linear decision surfaces, kernel methods, feature transformations came into picture, and our system evolved to represent non-linearity in the data, because we realized that assuming that all the data in the world that we get, whether it is tabular data or it is data in some other modality, is linear, was a false assumption, right? We wanted the ability to represent complex patterns. We wanted to do complex pattern recognition. So non-linear models, non-linear, the idea of non-linearity, using activation functions, using kernels, using feature transformations came into picture. Obviously that also gave the rise to neural networks, and which is where the deep learning started, right? So the 1990s to the 2010s, we evolved in giving rise to multiple neural networks, we wanted to teach our systems how to recognize complex patterns, to do certain classification problem, to do certain regression problem. Then we wanted to target each modality, right? We wanted to teach our systems how to see, how we wanted to give them vision. That's how convolutional neural networks were born, right? They were also based on the fundamental feed forward neural networks. They also had a feed forward pass and the backward pass, but the idea of convolution, the idea of introducing pooling came into picture. Then we wanted to do sequence modeling, gave rise to RNNs, or recurrent neural networks. Recurrent neural networks taught us, especially in deep learning, how to do sequence modeling, how to represent all of this continuous data as series of sequences, and then maybe use them to predict the next token or predict the next price of the stock, depending on what we were trying to model, right? So we already had multi-layer perceptron. We introduced recurrences and hidden states in them. The idea of memory came into picture. Then we saw that memory shortage is a problem, vanishing gradients is a problem. We wanted to evolve to something like a transformer. The transformers and the foundation models of today introduced the idea of attention, introduced the idea of context representation, then self head of attention, single head of attention, multiple heads of attention, cross attention between an encoder and a decoder. All of these mechanisms were internalized, and then we used the scaling laws to scale these transformers, which are nothing but today's GPT and today's large language models of the world. What exactly are these large language models? We know that they're probabilistic and stochastic models. They help us generate contextual and coherent text. Now these models, the large LLMs, also have evolved into large multi-model models, right? We are able to deal with multiple modalities of data. We now can encounter text, we can also encounter images, and we can also encounter videos. So we are able to deal with multiple modalities, right? So LLMs have now evolved into targeting not only text but different modalities. Now, we also have seen a rise to agentic AI. The current stage has also seen how agentic AI is helping us perform certain tasks. LLMs are the creative brain. The non-deterministic behavior is represented using the large language models. Now we want certain tools. So this brain should have certain arms and legs so that it can move and perform certain tasks. It should have certain memory. It should have some planning loops. It should have some feedbacks. So the idea of tools or tool usage, all of this ecosystem, which includes the non-deterministic behavior of large language models, then the tool uses, memory systems, feedback loops, all of these gave rise to agentic AI, right? Agentic AI is something where now we are shifting from the idea of generating, the idea of predicting, the idea of recognizing the pattern to acting. So agentic AI somehow seems that this might or might not lead us to the autonomous AI, to the AGI. So we can see that the agents are making decisions using all the tools that we give them, and the LLMs are able to generate a certain plan, a certain agenda for the task that is to be accomplished using these agentic AI and using the non-deterministic behavior. And we're also able to see that we have a certain feedback loop where we can observe what our actions, how our actions are affecting the environment, right? So agentic AI has been a crucial stage for us. But now when we are evolving towards AGI, obviously it's a speculative stage. It's not a real stage. It's a speculative stage, but we need to understand what all should we expect, or what all are we expecting. How do we even define AGI? Most of the deep neural networks that we have seen, before defining AGI, let us first try to understand. Most of the deep neural networks that we have seen have been great at solving a specific problem. Now, LLMs, especially when they became multimodal, kind of seem a bit generic, but they're still solving a very specific problem. But LLMs still seem to have decent amount of cross-domain intelligence, and somehow can represent human intelligence. The key insight for AGI is to not expect AI to do one task extremely well, but to do all the tasks extremely and reasonably well, especially better than skilled humans. So we will look at how DeepMind has defined AGI over the time using their taxonomy. They have certain levels of defining AI. So the first level is where we don't have any AI. So we are only doing narrow tasks. For example, simple calculators, the basic software, right? So we are way past the stage. So the level 0 has no AI. We can only do specific deterministic narrow tasks. The level one is the emerging AI, where we have equal to or slightly better than an unskilled human. So we have intelligence or we have performance where we are equal to or slightly better than an unskilled human. So for example, the older chat GPTs, the Claude 3, Llama 2, all of these models represent that particular stage. Now level 2, which is one level above the older models of chat GPT, is where we have competent AI, where we are outperforming 50% of the skilled adults. For example, the GPT 5.2 model, the thinking model. So level 3 is basically the expert AI, where we outperform 90% of the skilled adults, right? So specialized research agents. Now, when these thinking models are put to the deep research modes and we make them specialize and we also inculcate agentic behavior, this is the expert AI. So the level 4 is the virtuoso AI, where we are outperforming 99% of the skilled adults, right? So these are advanced, strategic, and scientific systems. So the level 5 is where we achieve superhuman intelligence and we are outperforming 100% of all the humans. So this is basically a theoretical, hypothetical, speculative future state. This is just the taxonomy or the capability definitions for AGI levels. So the idea or the narrative is such that we are emerging. So we are emerging AI state, and these LLMs or these models with the agentic AI capabilities might evolve to the superhuman intelligence, where we see a theoretical future state where the AI is able to do all the tasks better than 100% of the skilled humans. Now we have kind of seen that ASI or artificial superintelligence is the hypothetical stage where an AGI surpasses human intelligence by orders of magnitude. So there's a very famous philosopher known as Nick Bostrom. He also defines ASI as any intellect that radically outstrips the best human minds in every field, including scientific creativity, social skills, and general wisdom. So the relationship between AGI and ASI is often described through the concept of intelligent explosion. So this theory was first articulated by someone named Good, I think IJ Good, yeah, and later expanded by Nick, who is also the philosopher, and he has a lot of predictions around AI. They suggested that once an AGI reaches a human level ability to design AI systems, it can recursively improve its own architecture at computer speeds. So this is a very bold and very strong statement. So this feedback loop could lead to a rapid transition from human level intelligence, since it is now upgrading itself at computer speeds, to God level intelligence, and a moment often termed as singularity, right? So all of these terms, AGI, ASI, singularity, they have been talked about, especially whenever you see the founder of DeepMind come and give certain talks, and the Thinking Game, which is very recent documentary, and Sam Altman talk about AI. This is still a hypothetical stage, right? And we don't really know that how we are going to reach there. Some people say that we might reach there in 5 years. Some people say that we are decades away from reaching AGI, right? So, and we also don't have a lot of criteria for evaluating AGI, but we simply want to take away at least, the idea that we are going to have an AI, or we are expecting an AI to have cross domain intelligence that can see, that can understand language and model language, that can reason very well, that can plan very well, that also has motoring ability, that also has learning ability, and all of these abilities can also be, improvised or improved using a self-learning loop or a feedback loop, and the improvement is going to happen at computer speeds, right? Which is the term that they call as singularity. So when you achieve human like intelligence to god like intelligence, or when you evolve, when the AI evolves from human like intelligence to god like it, we are going to have a lot of discussions around AGI before we actually see AGI, and we are going to critique whether it's good for the society or not. But I think it's great to witness how technology is kind of shaping the current systems of AI, and how we are not even, let's say, 1% there to what AI is expected to do, or to what of these AI thought leaders are expecting the AI systems to do. I hope this video was useful, and we will tune in more and more episodes around AGI. So stay tuned. Cheers.